Hi dear students, in this video I am going to talk about competitive electron transfer. This topic is from the chapter Redox reactions. Competitive electron transfer. Electron transfer. In a beaker, copper sulfate solution is present. In a beaker, copper sulfate solution is present. CuSO4 aqueous. Color of the solution is blue. Aqueous copper sulfate is blue in color. In this solution, zinc rod is immersed. Zinc rod is immersed. Zinc solid. So after some time what happens? Color of the solution disappears. Earlier it is blue in color, now it will disappear. It will become as a colorless. And black coating of copper, it is formed on the zinc rod. This is dark brown black coating is formed on the zinc rod. That is due to following reaction. Zinc solid plus CuSO4 aqueous gives rise to ZnSO4 aqueous, which is a CuSO4 aqueous solution is blue in color. ZnSO4 aqueous solution is colorless. It is colorless, plus it will give Cu solid. Students, in the ionic form, this CuSO4 we can write it as Cu2 plus. We can rewrite this equation as ZnS plus Cu2 plus aqueous gives rise to Zn2 plus aqueous plus Cu solid. Here zinc is neutral, it is converting into Zn2 plus. It will convert into Zn2 plus by losing 2 electrons. Loss of electrons is called as oxidation. Zinc is undergoing oxidation. Meanwhile, the 2 electrons are accepted or gained by Cu2 plus, which is converting into the Cu solid. So plus 2 electrons. Gain of electrons is called as reduction. Loss of electrons is called as oxidation. Zinc is undergoing oxidation. Meanwhile, Cu2 plus is undergoing reduction by taking the 2 electrons. The reagent or the reactant which itself undergoing oxidation and reducing the other is called as reducing agent. Reducing agent. The reagent itself, it is undergoing reduction and oxidizing the other is called as oxidizing agent. Oxidizing agent. In the given reaction, reducing agent is zinc, oxidizing agent is Cu2 plus. So reverse, for example, if you want to store the copper sulfate solution in the zinc container, copper sulfate solution in the zinc container, CuSO4 aqueous, zinc container, it cannot be stored because zinc can displace the copper from the copper sulfate solution. Cannot be stored, right? If it is in the reverse, let us assume that the zinc sulfate solution is present in the copper container. Zinc sulfate solution ZnSO4 aqueous is present in copper container. Yes, we can store this because copper cannot displace the zinc. This can be done. Friends, let us discuss some other examples for this. Students, similarly, when copper rod is placed in silver nitrate solution, silver nitrate solution, AgNO3 aqueous. In this copper rod is placed. Then being copper is more reactive than the silver, displacement reaction takes place. This is Cu solid. Cu solid plus AgNO3 aqueous gives rise to CuNO3 twice plus Ag solid. Students, this ionic form of this equation we can write it as, you put, this is balanced equation, 2Ag, AgNO3, 2Ag solid. Cu solid plus 2Ag plus aqueous gives rise to Cu2 plus aqueous plus 2Ag solid. For copper, it is 0 to neutral charge to +2. So it is losing 2 electrons. Loss of electrons is called as oxidation. Meanwhile, Ag, 2Ag plus is converting into 2Ag solid by gaining 2 electrons. Gain of electrons is called as reduction. Loss of electrons is called as oxidation. Gain of electrons is called as reduction. So in this, the reagent which itself it is undergoing oxidation, reducing the other is called as reducing agent. Cu will be the reducing agent, and Ag plus which itself undergoing reduction will be the oxidizing agent. Students, similarly, cobalt solid reaction with Ni2 plus aqueous, then it will give us CO2 plus aqueous plus Ni solid. Here CO0 to CO plus 2 minus 2 electrons. Loss of electrons is called as oxidation. Gain of electrons, Ni, nickel, plus 2 to 0, plus 2 electrons. Gain of electrons is called as reduction. Loss of electrons is called as oxidation. Thanks for watching.